In this video, what we're going to do is we're going to explore how to use the constant of proportionality to write equations and to explore some of the relationships between two different quantities. So this is just an extension of the bamboo problem where we're told at the very beginning that for every 1 day, the bamboo grows 60 centimeters. So we're given a ratio here, or really a rate, to be able to do this comparison. So what I'm going to do is I'm going to use this rate to fill in the rest of this table. And so here's what I know. In 10 days, so that's going to be times 10, I'll times 60 by 10, it's going to grow 600 centimeters. 30 days, I'm just going to scale that by multiplying by 3. I'll do the same thing over here, multiply by 3, get 1,800. 1/2, well, what I'll do there is I'll actually just divide that by 60 to scale it. I'll do the same thing here, which gives me a total of 30. And then I get my harder ones, 20 and 200. 20 is going to be 1/3 of a day, and 300 times 10, I guess, would be 10/3, or would be 3 and 1/3 day. So I have this table filled out. Now, the constant of proportionality is really about recognizing, do we have a constant ratio between these things? So what I'm going to do is I'm actually going to put over here the ratio that exists between time and height. And so in my first example, that ratio is 10 over 60, which simplifies to, 10 over 600, which simplifies to 1 over 60. And if I actually do all of these, I'll find out that for all of them, that time to height ratio is 1 day to 60 centimeters every single time. I get 1 day to 60 centimeters, which, if you notice, is the exact same thing as that initial relationship that we were given when the question started. So because this is a constant ratio, this is what we call our constant of proportionality. Or in other words, okay, the constant of proportionality between time and height is 1 over 60. And the reason why that works is if you actually just put some values in there, what we have is we have time and height, and then that gives us our 1 day to 60 centimeters. So there is our constant of proportionality between time and height. Now, we can also, just like we can find reciprocal ratios and reciprocal rates, we can also find the reciprocal constant of proportionality. So I'm going to now find the constant of proportionality that exists between height and time. And to do that, all I do is I take this work and I just turn it over. I make it the reciprocal. I'm now going to compare height to time, and by doing the work that I've done, I can see that it's 60 centimeters for every 1 day, which also, if you notice, is also a unit rate, because we are comparing something for every 1 day. So this is how we can find the constant of proportionality. And all that it is, it's just a measure of what's that constant ratio that connects these two things that we're comparing. So in this case, it's time and height. Well, what we can do now is we can use the constant of proportionality to write an equation showing the relationship between days and height. So what we're going to do is we're going to set up a proportion that connects days and height. So I'm going to start with those words, days and height. And I'm just going to take a peek back at the previous work. That days and height, or that time and height, was 1 day to 60 centimeters. So that was 1 day to 60 centimeters. Now remember, once again, this here, that's that constant of proportionality. And so all I'm going to do now is I'm going to give me some variables to work with. So I'm going to call days D, and I'll call height H. And now I'm just going to kind of package that all together. I know that D over H is equal to 1 over 60. It's 1 day, 60 centimeters, or the height is 60. So now to make that an equation, because I want to focus on finding days, I'm going to have days by itself, and now I have to somehow rearrange this to get everything else on the opposite side. So this is where our equation solving comes in, and I recognize, well, wait a second, if I multiply this by h, those h's are going to cancel out, but I have to do the same thing over here, and so now I get a final equation of d equals 1/60th h. And this becomes our equation. And if you think about it, it makes sense, right? Really what we're saying is that we're saying that for every 1 day, the height changes by 60 centimeters. Or if I want to know how many days something's been growing, I take the height and I multiply it by 1/60th, or divide by 60. So we're going to actually use that equation now to do some work. So here's what I've got. I've got my equation, d equals 1 over 60h. And I'm being told I want to find the height of a bamboo plant, so I want to find h, and I've been given a time of 3 days and 6 hours. Now that's not exactly straightforward here, because 6 hours is a portion or a fraction of a day. And that's where this equation work is actually really great, because it allows us to work with continuous data sets. So 6 hours is really 6 out of 24 hours in a day, which is 1/4. So really we're talking about 3 days and another quarter day, or as a decimal, 3.25. So I'm going to take that value for d and put it into my equation. So I know that something's been growing for 3¼ days, and I'm going to use that to calculate the height of the plant. So this is now equation solving again, and I'm going to multiply by the multiplicative inverse, or the reciprocal, of 1 over 60. So 60 over 1, sorry, that's kind of small. And I'll do the same thing over here, 60 over 1. And now because I'm using calculators, this is a great time to use my calculator. I'll get my calculator out, and I'll multiply 3.25 times 60. So I know that's 180, and then a quarter of 60 is 15. So 195 equals h, or 195 centimeters in 3 days and 6 hours. Now just so you know, that it can work the opposite way as well. I can use the constant proportionality to write an equation connecting height and days. So to do that, we'll do this really fast this time. So now I'm going to set up my original ratio of height and days, and actually just to speed it up, we'll use our same variables, h and d, and I know that that equals 60 over 1. So notice that it's just the reciprocal again. Well, I want to now find the equation for h equals, and in this case, if I multiply through by d on both sides, multiply by d and multiply by d, those cancel out, and I'm left with an equation of h equals 60d, which also makes sense. For every day, I multiply that by 60, and I get the height. So now I can do the same thing down here. This is just the exact same question, but because I'm using a different equation, it's going to work out just a tiny bit differently. 60d, we worked out before that d equals 3.25. So now I'm just going to substitute that back in. H equals 60 times 3.25. I grab my calculator, and I get h equals 195. So same answer, just using a different equation. So just to recap, the whole point of this is for us to be able to start with some data, determine the constant of proportionality. Notice that there's 2 of them depending on how we organize the relationship. Take that constant, turn it into an equation, and then use that equation to find out additional information. So hopefully this will help you in your work with the constant of proportionality.